So, yes, I'm director of Estonian Entrepreneurship University of Applied Sciences. I also have 20 plus years experience in high technology manufacturing and also in academia, some experience also in endurance sports. We can discuss about all today, but indeed today we will discuss about quantum computers and the potential that is behind the quantum computers. The need for computing power that was clearly coming visible from Timo's first presentation in the morning, and also it was clearly visible from Rian's presentation that there is strong need for the really extensive computing power in the future, and quantum computing is one of the technologies which really will have the potential to provide this. The worldwide, so that will be technology indeed that will change the world. At the moment in 2024, the quantum computer market value is around $1.3 billion. It is expected to grow to the level of $5.3 billion by 2029. That is due to the fact that more and more companies will be investing into these new technologies. Many industries already are using quantum technology, like healthcare, pharmaceutics, automotive, transportation, financial services. They are already making first steps, practical steps there. There is also coming from the industry of education. There is also there will be high number of new well-paid jobs in this field, in the field of quantum computing, and there will be need for scientists, engineers, programmers. At the very moment, even the entry-level jobs in quantum computing, they can pay 6-figure salaries. So it's also expected that this field will explode, and that there will be many new exciting opportunities for those who love the science, mathematics, and computers. Way to quantum computing. There has been waves in computer developments, and indeed we used to have around 100 years ago analog computers, then switching to the desktop boxes and different large facilities, and then now everybody is carrying basically supercomputer in the pocket already. The smaller the computer gets, the more powerful they seem to become, and there is indeed much more computing power in your pocket at the moment than, for example, 1985, the supercomputer Cray. This one had energy consumption of 200 kilowatts. It's like a small factory. And the price for this one was $16 million. Its performance was 1.9 billion flops, that is the floating point operations per second, 1.9 billion. Now the iPhone 12 has 11 trillion flops. There is huge gap already between what used to be just recently and what we have at the very moment. As Moore's law, by Gordon Moore, he stated, one of the founders of Intel Corporation, somewhere in 1964, stated that the number of transistors on the chip will double every 2 years. And it has been valid from 1964 up to now. The trouble is that the transistors, they are just as small as we can make these. And it's part of the challenges also for Jan Raik, I'm confident. But basically we are now getting to the point where the laws of physics are likely to put stop on the further progress of the Moore's law and development of chips also. So that is just a processor for one USB device having 500 megabytes of data, and this one has 4 billion transistors on the size of basically postage stamp. In 1970, Intel had 2,000 transistors on the chip. Now already it's in i9, which is in series production, it has 10 billion transistors. For AI, it's 100 billion. And I saw on Jan's presentation, it was even much higher, the number which can be out there. So basically, the transistors today, they are on the size of 20 atoms or less, approximately. And once the transistor reaches the size of 5 atoms across, things will get very interesting. Basically, the technology will be obsolete, since at that point, the Heisenberg uncertainty will kick in, and we do not know anymore where exactly the electron is, and the transistor will short circuit. It doesn't operate anymore. So we cannot go much smaller with the transistors. And the solution is we need to switch to the world of quantum mechanical. IBM has developed transistors with the size of 2 nanometers. That is 14 atoms across. And then 1 nanometer is 1 millionth of a meter. So we are talking about very, very small dimensions. But indeed, this problem is one of the reasons why science and technology is now looking very keenly to the direction of quantum computing. Before we have just a brief insight on quantum mechanics and what is behind, let's see what some of the wise men have said about quantum computing. We start with Niels Bohr. He invented the modern model of atom, and he found that the idea that the electrons, they travel in discrete orbits around the atom's nucleus, and each orbit is corresponding to the specific energy levels. He received Nobel Prize on his work 1922, and indeed he had specific comment on the field. Albert Einstein, the same. His contribution to the world of quantum physics was he invented the dual nature of the photon, meaning that there is the particle duality. Photon is working or acting like wave particle and particle, and having also particle like properties. So for this, he received Nobel Prize in 1921. My favorite quote on the quantum mechanics and is coming from Richard Feynman, and he is actually behind. He developed a comprehensive theory that describes how light and the matter interact, and also he is behind on quantum electrodynamics, and then really saying safely that nobody understands quantum mechanics, I believe is quite valid, since the field is really specific and unique, and coming from normal world, it's very difficult to cope and understand. In principle, the quantum theory, it deals with the world of atoms and the smaller subatomic particles inside them. So rules of classical physics and computing, they do not apply in this world. Some of the fundamental key principles behind or in describing the quantum world, we start with superposition. As you know, in the classical computers and computing systems, also what Jan Raik is describing, we are having 2 states. The bits can be either 1 or 0. there is no fuzzy conditions in between. The quantum world is much more special. The qubit, which is the quantum bit, it can be 1 or 0 or any other value between 1 and 0, all at the same time. That's very hard to understand. At the same time, it can have all these values. So this property allows quantum computers to process vast amount of information instantaneously at the same moment. The second very unique property in the quantum world is entanglement. And that is the phenomenon where qubits become interconnected so that the state of one qubit directly affects the state of another. And also no matter the distance between these qubits, that is providing also quantum computers to perform really complex calculations and run them massively in parallel. These entangled components, they stay connected even by separated large distances. What is unique is that the largest distance at the moment scientifically proven is between the Earth and the satellite orbiting around the Earth, 1,200 kilometers, and the entanglement was still working. That was big puzzlement even for Albert Einstein, because it happens simultaneously and it's basically happening faster than speed of light, so very difficult to understand. Also there is issue, recently scientists have proven that human brain might have also quantum entanglement involved in its operations, and that could explain some of the unique behaviors and uniqueness for the human brain. There is interference in quantum particles. Systems can interfere with each other, and they can, which can be used to amplify the correct answers and phase out or delete the wrong answers during computation. There's also the coherence, which is the process in which quantum system is losing its quantum behavior and transition to classical stage. Managing this is quite vital also for the quantum computations. So quantum computers, let's take a big step already and then skip some of the details. Some facts about quantum computers. How much do they cost? They are actually out there already. You can buy them. The entry-level quantum computer is costing around $5 million at the moment for basic operations. Medium range quantum computers that can provide some more advanced features. The cost is tens of millions of US at the moment. And advanced or high-end quantum computers with really superior capabilities, their prices exceed hundreds of millions US. IBM has the quantum computers already almost in series production. They do offer quantum computing services on pay-as-you-go basis, and all of us, all of you, we can use the quantum computers with IBM for the cost of $100 per minute. Now let's have a look at quantum computers. Everybody most likely has seen something similar, this kind of picture, and that is actually the dilution refrigerator for inside quantum computer, and each of the level in this dilution refrigerator is cooled down further. So the quantum chip, which actually is very small, just a size of few centimeters, is sitting down here at the bottom of this dilution refrigerator. And what is unique is also that it has been cooled down to the level of 15 millikelvins. That is just above absolute zero. And actually this temperature is cooler than the vacuum of the space. That is needed because it's very sensitive to any external distributions for heat, for vibration, electromagnetic waves. All this will basically destroy the quantum states, and we will not have any proper results from the machine. Actually, there is the operational picture of quantum computer, and you can see that it basically consists of normal computer, traditional computer, and the quantum part. So, yeah, both of them are involved, and the user is sending task from the normal computer. The task will be sent to the cloud. It will be queued and then sent to the further to the control computer, and that is making this mixed signal, the frequency that can be digitized, and then this signal is moving now to the quantum part of the quantum computer. It will have the interaction with qubits, and now the signal is moving back through the amplifier back to the normal computer, where this signal is processed again, and actually at the end of the flow converted back to ones and then zeros. I have to speed up because it seems that the previous presentations they took more time, so I will skip some of the details. But comparison on the speeds, just to give you some insight how much faster quantum computers are. 3 comparisons have been done recently. First with Google, and they made really fascinating comparison in 2019. Their quantum computer performed specific task in 200 seconds that would have taken the world's fastest supercomputer at that moment 10,000 years to complete. That is really showing this, they call it quantum supremacy, the potential behind quantum computers. IBM made experiment in 2023. They were measuring the specific movements of small particles. They were running the operations in parallel with quantum computer and the supercomputer. The supercomputer was actually getting stuck between the complexity behind the high number of particles and all the need for high calculations. So it didn't complete the task. The quantum computer completed task fluently. Chinese guys, they have very strong interest also in quantum computing. They made experiment in 2020, and they were stating that their quantum computer is performing 100 trillion times faster than the world's fastest supercomputer. That is truly unique, because these supercomputers, they are very fast also. I have here slide on I was looking which is the world's fastest supercomputer at the very moment. That is the Frontier, based in US. It is operating on 1.2 exaflops. If anybody knows how many zeros exa has 18 zeros behind 10, and it's operating this much operations in every second. So huge capability for modern supercomputers also, and quantum is still exceeding this by far. Concerning quantum, indeed, we are not there. It's not so green for quantum computers, and they are not definitely mature. They are in early phases. There are many issues in decoherence and noise, meaning noises coming from the environment. As you saw, it has to be very solid and secure, no disturbances. There is also issue on error rates and correction, because getting the right data out of this fast amount of data. It needs a lot of correction and specific fine-tuning indeed. Scalability is a big issue. Having more qubits built into a quantum computer is not definitely easy. Hardware development is challenging. Also, there is complexity and as you also cost related to quantum computers. So in the near term, the most feasible approaches, they seem to be that there is combination between classical and quantum computer to get the best results. Few fields where the quantum computers can really excel and provide the best properties. Cryptography, definitely encryptions. There will not be any digital code that the quantum computer could not crack or open almost immediately. So it's a new world. Simulating molecular structures, discoveries of new drugs, a lot of computing power is needed, and indeed we have seen already that quantum computing will be behind of creation of new drugs for medicine. That is very beneficial basically for the full mankind also, since these developments will greatly support to exceed the life expectancy for all of us, and getting cured on many issues which we are not at the moment able to do. Artificial intelligence will gain a lot from quantum machine learning. The speed and capabilities will grow a lot. There is also possibility for network connected quantum computers which will further increase these possibilities. Financial modeling, definitely. Climate modeling, as you know, calculating and predicting climate is one of the issues which is really requiring a lot of calculation power, calculation and computational power. Using quantum computers will greatly improve the quality for the predictions. Also, new materials will emerge definitely with the help of quantum computers. In basic operations, supply chain development, logistics, the complexity will be supported by quantum computers and helping to take down the cost in different supply chains. More technologies definitely will be coming and added to this list. As final slide, I have brief insight to you from 2014. I published article development of AI towards singularity. That is quite unique, and singularity. We heard earlier that somebody will develop this machine which will be really smart, so that it will already build its own follow-up, and actually it will be happening most likely pretty soon, considering the development in AI, in artificial intelligence, and this moment has been named as the point of singularity, where the smart system, the artificial intelligence, will gain its own consciousness, and it will start setting its own targets and goals, and starts fulfilling these also. So human involvement is no longer needed to support the further development of technology. And there are different opinions when this will happen. Ray Kurzweil, one of the front speakers in this field, he feels that it will take place somewhere in 2045. So still we have way to go. Elon Musk has just recently stated that it will take place in 2025 already, so basically next year. So it's a bit spooky. But basically, what it means that after this point, the point of singularity, the speed for development of technology, it will greatly exceed. It will not depend on humans anymore, and us with weekends and then holidays and then different issues that every human needs. It will develop very fast. And my conclusion in this publication was based on the Moore's law that I stated that somewhere in 1965, Gordon Moore stated that the computing or capabilities, they start doubling every 2 years. it has been valid since then, and actually it has been accelerating. So after this moment of singularity, the speed of this development will continue. What is very interesting is that the Moore's law is valid also while looking back to the history. It's valid there also. So my conclusion was, and then kind of it seems that it's still valid, is that us humans, the carbon-based intelligence, in the development of kind of universal intelligence, we represent small section only in this history. And after us, the intelligence will continue to develop, but now run by quantum computers already, and then silicon-based intelligence. And quantum computers will play quite vital role in this field. So that was my brief insight to the fascinating world of quantum computers and development of intelligence.
Thank you very much. We've received a few questions. Now Andrus will stay throughout the day, and we will finish this day with a panel discussion where you will have more opportunities to ask. But before our last presentation, before lunch, one very fundamental question was asked: how to avoid war between smart machines and humans, because it does seem that a human being is not really an important player quite soon anymore.
That's a very good question, and indeed there are many scenarios looking to the future, and indeed if we are not acting properly now, meaning that we are not securing the system with correct DNA, after this point of singularity, the system actually will start managing it its own way, and then it will be too late to influence this. So at the moment, having the proper regulatory setup in place, and then making sure that after the point of singularity, the AI and the technology has humans in the loop.
Should we be excited about AI and quantum computing, or should we be afraid of
I would say we have to be very much excited, because the field of new opportunities is endless, and indeed concerning new materials, basically new level of living and existing for humans. That is something which is hard to understand at the moment, but by doing properly, that will definitely very much beneficial for humans.
I hope we will not meet next time in the Matrix, but we'll be still in charge.
And what is unique, that we might be still in the Matrix, and then we actually might be having our consciousness in the Matrix, despite our physical bodies maybe not being available any longer. So we can still communicate in the Matrix far back to the distant future.
So the red pill or the blue pill, Andrus, first?
Exactly.
We'll see.
Yeah.
Thank you very much. We'll continue the discussion in the panel with Andrus.